In this video, we're going to be going over the week 4 independent practice for the Monday column, which asks that we solve the two-step inequality. So we don't have to graph the inequalities or anything, we just need to solve them out. And in order to solve out two-step inequalities, they need to be done or I recommend that they're done in a certain order, and that is to do the addition subtraction part first and then your multiplication division part. So in this first example, we have that 35 is greater than 5w plus 15. So we're being asked to solve. What does it mean to solve an inequality? It means to get the variable by itself, because then we're going to know what can the variable equal. Can it be numbers that are going to be greater than 7, less than 7, and so on. So there is an algorithm or a technique that we can use in order to solve any two-step inequality, and that's to do PEMDAS backwards. And what I mean by that's just kind of my cheesy way. That's not really like the mathematical way of saying it, but that's just my way of helping you remember that you're going to need to do addition and subtraction first before your multiplication division. Do you have to do it that way? No, not necessarily, but I think that's the easier way of doing it. So what that means is that I want to take care of this plus 15 first before I do get rid of that 5 times the w. So if I want to get rid of that plus 15, I want to zero that out. I'm going to need to subtract 15, because that's a positive 15 that we've got here. And to turn a positive 15 into a 0, I'd subtract 15. And we can also see that these are opposites of one another, and opposites cancel out. And so that's going to leave me with 35. Oh, almost messed up there. If I subtracted from the right side, I need to subtract from the left side as well. That's going to leave me with 20 is greater than 5w plus 0, but anything plus 0 is just the same value, so we're just going to say plus 5 is going to be 5w, 5 times w. Now, I still have a 5 attached to the w, and I want to get that w by itself, so the next thing that I'm going to need to do here is I'm going to need to cancel that 5 out by placing it over itself, which means to divide both sides by 5. When I divide both sides by 5, because it's a positive 5, I don't need to flip the sign, and then I'll be left with just a w on the right side, and on the left side, 20 divided by 5 is 4, and so I'm left that w is all values less than 4. What does that actually mean, though? What that means is that taking any value, as long as it's less than 4, and substituting it into our original inequality is going to give me a statement that is true. It's going to give me a true statement. For example, if I decided that I was going to plug in any number less than 4, let's say 2. If I was going to plug in 2, that'd be 5 times 2 substituted in for w plus 15, and we should get a true inequality in this case. Well, 35 is greater than, this is going to be 10 plus 15 is 25. 35 is greater than 25. That's a true statement. And so that just goes to show you that there's going to be an infinite number of solutions. We could have plugged in a 1, 0, -1, -2, -3, all the way to negative infinity, and that would have given us a true statement. And so that's what that goes to show you, is that you can plug in any value into w as long as it's less than 4, and you're going to get a true statement. If you plug in 4 or any number greater than 4, then you're going to get a false statement. And so that's what it means to solve the two-step inequalities. And the algorithm that we use is that we solve for addition subtraction first before multiplication division. Let's do another problem. We've got negative 6m minus 5 is greater than 13. So again, going to take care of the number that's not attached to the variable. So I've got two options here. I can either take care of this negative 6 or take care of this 5. Well, it's going to be, the easiest step here is going to be to get rid of that minus 5 by adding 5 to both sides, which is going to leave me with negative 6m is greater than 18. Following that, I'm going to divide both sides by negative 6, because negative 6 over itself is going to be 1m, which is really just m, is going to be on the right side will be a negative 3. And because I divided by a negative 6, I need to flip my sign. I need to turn that into a less than. M is going to be values that are less than -3. And just to remind you, the reason that we flip the sign is because our expressions on both sides, they also flip signs when we divided by that negative number. This went from being a positive 18 to now a -3. So it went from being positive to negative, and same thing over here, we went from a negative expression to a positive expression. And so because they changed their sign, we also have to flip the inequality sign in the middle for it to still give us true statements. And if we were to make out a table of values that we could plug in, you'd see that we would need to flip that sign in order for it to make sense. Number 3, 6 is less than -42 minus 2 times c. We're going to take care of the number that's not attached to the variable first, so we're going to need to take care of this -42. Well, if that's -42, and something interesting happens here. If that's -42, in order to zero that out, I'm going to do the opposite. I'm going to add 42 to both sides, which is going to leave me with 48 is less than 0. And this minus 2c, that's going to become a negative 2c because we didn't get rid of that minus sign. So that minus sign essentially becomes a negative sign. And that's true also because if we did a keep change on here, it would become a plus -2c, and we would just bring that -2c down. So that's a common mistake I see, is that minus sign that ends up going away, but it never actually went away. Instead, it turned into a negative sign is how we read it now. I want to get that c next to a 1, so I'm going to divide both sides by -2. Dividing both sides by -2 means that I'm going to need to flip my sign, and then I'll put whatever's left over into my inequality. All right, we've just got 3 more. I'm going to go ahead and leave that 4th one for you. Hopefully you can knock it out pretty straightforward. Now the last 2 require some distributive property. But you can also do these without the distributive property. Let me show you what I mean by that. This is -9 times the quantity of n minus 2. This is a multiplication operation. And what we regularly do for these problems is that we distribute them into the values that are inside. But the thing about this is that you can divide both sides by the number outside of the parentheses. And when you do that, that -9 on the top here and this -9 on the bottom actually cancel out, because -9 divided by -9 is just 1, and leave you with n minus 2 is less than, because we divided by a negative number, -2. And then if we distribute this 1 here that we got from dividing the -9s, that's still just going to be n minus 2. So as you can see, what happened here is that we got rid of that number outside of the parentheses, and that becomes really useful whenever we're doing fractions or decimals. Being able to get rid of it first rather than having to distribute it makes it a lot simpler. And then now to get the n by itself, I would add 2 to both sides, which is going to leave me that n is less than 0. And this confuses some people. You got some people messed up whenever they see that 0. Yes, n can still be less than 0 because that's still an infinite number of solutions. There are an infinite number of numbers or integers to the left of 0, all the way to -infinity. For the last one, I want you to practice that same thing we just did. You're going to get rid of that -6 first rather than distribute it into the expression within the parentheses. I want you to get rid of it first. So divide both sides by -6 first, and then after that, subtract that 1/2. Or if you don't feel comfortable with that, then maybe do it the other way around. Just whatever you feel is going to work easiest for you is fine with me. Just as long as you get to the right answer, I'm totally all right with it.